Kia ora Year 12. This is question 5 from exercise 8b, requested by Tim, and it's a really nice old exam question that's got lots of different calculus skills in it. So let's have a look at the question overall before we start. Well, we're given a function, and it's this function here. You can see that it's a product of a linear thing times an exponential. We have to start off by differentiating. Then we have to find this integral. So you can kind of guess that this and this are going to be somehow linked up. Then we have to find the coordinates of the stationary point on that curve, and we're going to call that point S. And then we have to find, oh, something's happened to my writing. We have to find the second derivative at that stationary point and interpret it, say what it means. Then we have to show that if we do this substitution, we can convert this integral back into this one. And lastly, we have to do it as some definite integration. Okay, so let's get going. I'm going to go reasonably slowly on this. Right, so we've got y equals x plus 3 times e to the negative x. This is going to be a product rule. So here's my u and here's my v. So what's dy by dx? Well, dy by dx is going to be the first, x plus 3, times the derivative of the second, plus the second, e to the negative x, times the derivative of the first, which is 1. Now I'm going to clean that up and factorise. That's going to give me this, e to the negative x times, now I might do this bit first because it's a positive, so 1 minus x minus 3, which gives me e to the negative x times negative x minus 2, and that equals negative x plus 2 times e to the negative x. So let's look at why I bothered to do that. Well, it's because I've read the whole question first, right? And I can see that the thing I'm finding here has to link to that first derivative, and it's written in a nicely simplified form. If instead I were doing level 3 calc, and I could just see that they wanted me to show that I could use the product rule, then it would actually be fine to stop here. But you can see that's a really ugly place to stop. So we keep on going and we factorise it all the way through. So now we've got this, that dy by dx is equal to negative x plus 2 divided by e to the x. So that brings me on to the second part, where we have to find this integral. So we've got x plus 2 over e to the x dx. That's one that we wouldn't want to do. If we hadn't done all that first part of work, it looks pretty icky, okay, because I've got a fraction, and I know that fractions are easy if I've got this pattern. Right, so if I've got that pattern, then that's come from the natural log of f of x plus c. But I haven't got that in this case. But I've just differentiated something and ended up with the result. So that means that this integral has come from negative x plus 3 e to the negative x. Right, now it's negative because when I differentiated up here, I had negative x plus 2, and I haven't got that down here. So that's part 2 done. Now the next thing we have to do is to find the stationary points on the curve. So we should say that. So at point S, we must have the gradient equals 0. So we're solving this. So either x plus 2 equals 0, or e to the negative x equals 0. Think about what that graph looks like. So there's my e to the negative x. It never equals 0, so I get no solution here. And here I get x is equal to negative 2. We're asked for the coordinates, so I need to substitute that back in. We know that y is equal to negative, y is equal to what? Let's see. Y is equal to x plus 3 times e to the negative x. So y is equal to negative 2 plus 3 times e to the power of negative 2. What have I done wrong here? Is that right? I think that's right. What does that give me? So y is equal to No, y is equal to negative 2, y is equal to 2, y is equal to e squared. So point S is equal to negative 2 and then e squared. I'm just checking that I haven't mucked up the sign there. I know, someone please leave me a comment if I have stuffed that up, but I think that's right. I actually haven't checked the answers in the back here. So we've got that point. Now the next thing we've got to do is to find the second derivative. So we've got dy by dx is equal to negative x plus 2 times e to the negative x. We need to do the product rule again. So we'll treat this as u, the first function, and this is v. So we have u times v dash plus v times u dash. Let's clean that up. We get e to the negative x times x plus 2 minus 1, which gives me e to the negative x times x plus 1. So at x equals negative 2, the second derivative is equal to e squared times negative 2 plus 1, which is negative e squared, which is less than 0. So we've got a maximum at point S. So that's the first few bits done. Now, Tim, I suspect that's not the bit that you wanted a hand with. Let's have a look. What have we got now? So we now have to do the substitution. Okay. So we're going to do a u substitution, and we're going to try and switch one integral into another. So when we do substitution, we just have to make sure that we convert all of the bits. So if u is equal to e to the power of x, then the first thing I'm going to do is to differentiate it with respect to x, and I get this. Now the new method that we've learned is that we can separate that du and dx and rewrite it like this. So du is equal to e to the x times dx. And we're asked to convert from a u integral into this x integral. So if you think about what I've got to do, I've got to go through this integral here and change everything over from being something with u to something with x. So we've now got a way to substitute for the du, and we've got u equals e to the x, so we can do the u squared. The last thing that we have to deal with is the numerator, so we know that the log of u is equal to x. And I've put all of those things into little boxes. Now we're good to go. So moving over to here, what have we got? Well, we're starting with this, 2 plus the log of u over u squared du. We change each bit. We've got 2 plus x over e to the 2x for the u squared, and then for du we've got e to the x dx. And because it's a show that question, you need to make sure you've got that much working in there. Okay, so here we go. That's the first bit done. Now the last part of the question was to evaluate this definite integral here. Okay, and we're just about there. We know from that work we just did that if we've got an integral of this form, we can rewrite it like this. The only tricky bit left, oops, turn off into shape, the only tricky bit left is to change my limits of integration. So we've got from e to 1, 2 plus the log of u over u squared, and we've done all of this bit. We've got 2 plus x over e to the x dx. So we need a little table that switches us out. So here we've got our u limits. They are e and 1. And here we've got our x limits. So we know that x is equal to the natural log of u. So x is equal to the log of e, which is 1, and the log of 1, which is 0. But going all the way back to the start of the question, we know that this is equal to the integral of this function in here. Substituting into here, what do I get? Well, I get negative 1 plus 3 times e to the negative 1 minus negative 3 times e to the power of 0. That gives me negative 4 over e plus 3, or more nicely written out, 3 minus 4 over e. So there you go. That was actually quite a long video because that question had 6 little parts to it. So hopefully that made sense. I've had another request come in for 8C number 5, so I might do that now as well. Thanks for watching. Let me know if it helped.